Okay, section 4 here is one of the easier sections in this chapter. There's really only one theorem, and it's just a matter of recognizing it and seeing it in these problems. So the theorem is all the way right here. Okay, so basically the theorem is, and we sort of hinted at this in the last section, but basically when you have an isosceles triangle, let's say the sides are congruent to each other like this, well, that means that the base angles are congruent to each other like this, and vice versa. So what you'll see on a lot of proofs is you'll see if sides, then angles, or you'll see if angles, then you know the sides are congruent to each other. Okay, so this is the new material for this section. Basically, it allows you to skip the step where it says isosceles. And there's really only one proof that I want to go over, and that is the very first proof on the next page. So let's do that. So here's the proof that I want to take a look at. It's given that these are isosceles triangles, so this is congruent to this. And we also know that this is congruent to this. And because we know that they share DC, we know that they're all congruent to each other. So we'll get to that. You also know that this angle right here is congruent to this angle. And you're trying to get that EF is congruent to FB. Now I could try to go after the bow tie triangles here that are kind of like in the middle, here and here. But I'm guessing from the given information that we actually need to prove these overlapping triangles congruent to each other first. Okay, so let's do that. Let's prove the overlapping triangles. So we have the isosceles givens. Step 2, I know that ED is congruent to DC. I also know that BC is congruent to DC. So if isosceles, then the sides are congruent. And from this, I know that they're both congruent to the same segment, so I know that ED is congruent to BC. That's just the transitive property step. And in step 4 here, I can say that, see, that gives me a side. I can say that DC is congruent to itself, right? Whenever you have overlapping triangles, you're going to end up with some sort of reflexive here. So here's my reflexive. Step 5, I know that this is true. That's given. That's going to be, so this is my side, this is going to be my angle here. So step 6, I know that triangle EDC is congruent to triangle BCD by SAS from steps 3, 4, 5. And now, here's the tricky part. I know that CPCTC tells me that EC is congruent to BD. I also know that angle FCD is congruent to angle FDC. Okay, those are both CPCTCs that we're going to need for the next part. Step 8, if I know that these angles are congruent to each other, then I know that FD is congruent to FC. There's the theorem from this particular unit. And so if angles, then you know the sides are congruent to each other. And hopefully you can see that because of that, now I can go use the other CPCTC and I can just do a subtraction property. So EF is congruent to FB by subtraction, and we are done. All right, I'm going to skip that proof on the bottom there. It is kind of a crazy proof. There's a lot of different ways you can do that proof. Go ahead and try it though, if you get a chance. Fun little 4-level proof. Okay, take care.